Hello friends, in this video we are going to learn how to solve the quadratic equations having real solutions by using set square only. So we are not going to use the algebraic formula to solve the equation, but we'll simply use the geometry to solve it. So let's get started. I have divided the quadratic equations into 4 examples such that the coefficients have different signs in them. So these 4 quadratic equations will represent every type of quadratic equations, and I have taken the coefficients a, b and c as positive, and the alternations in sign will include all the type of quadratic equations, and we have assumed b squared minus 4ac is greater than or equals to 0 so that it will give the real roots only. So let's get started. First, what you need to know is you need to remember the anticlockwise direction is taken to be positive. So I'll take a simple example like this of quadratic equation, then we will work stepwise, then we will be clear. At first we are going to look this coefficient, which is 2, then draw a vertical line segment having length of 2 units. We'll look the second coefficient, that is 5, and the sign is plus, so we draw a line segment of 5 units by going in 90 degree to anticlockwise direction like this. Here, to draw a line perpendicular to any line, you need to put the set square in this position, but since I do not have markings in this edge, so I am just using the reference of these line markings to get a line perpendicular to this line. So let's draw a line segment of 5 units like this. Then look at the constant on 3 and its sign is positive, so we draw a line segment of length 3 by rotating 90 degree anticlockwise like this. Then the main part starts over here. We need to put the set square in this box in such a way that the edges are just touching the corners at here and here, and the vertex is just touching the blue line like this. And you can just do heat and trial to get this position. And let's draw a line connecting these 2 edges. But as you can see, there are 2 different possible solutions of keeping the set square in this position. The next position is like this. The next step is you just look to this red line and mark a point at a distance of 1 units from here to here. So this is just the same figure that I have drawn, but with 2 possible solutions. So here also let's mark a point at a distance of 1 cm from this corner. Then we draw a horizontal line starting from this point to this line, and here also we draw a horizontal line starting from this point to this line. Then it will look like this. Then we just measure the distance from here to here and measure the distance of this horizontal line. So this horizontal line is 1.5 cm and this is 1 cm. As we can see, the solutions of this quadratic equation is also x equals minus 1.5 and minus 1, since this horizontal line lies on the left side of this red line in this side, hence this is negative. Here also this line segment 1 is on the left side of this red line, hence it's in negative, so the solutions are minus 1.5 and minus 1. Let's do a similar example. Now I'll change the sign of the coefficient b and then we'll proceed. First, draw a vertical line with the length of 2 units. Then draw a line segment with a length of 5 units, but in clockwise direction since there is a minus sign. So we draw like this. Then since we have already changed the direction to be clockwise, now we'll proceed on with the same direction or clockwise until we get another negative sign in it. Hence, let's see the constant term, which is 3. So let's draw a line segment of length 3 by moving 90° clockwise. Then we repeat the same process as before. We get some hidden trial positions to find a certain position of set square such that the two edges are touching the corners and the vertex is touching the blue line. Then we draw the line connecting these corners and the vertex like this. In this question also we find the two solutions for this quadratic equation, so we can find the two positions for the set square to be in this position. One is this position and the second one is this position. Then we again go to the red line and mark a point at a distance of 1 unit from the end. And here also we mark a point at a distance of 1 unit from the end. Then we draw a horizontal line starting from this point to the black line, like this and like this. Then at last we measure the distance of this horizontal line, which will give us the result. So the length of this line segment is 1.5, this length is 1, and since this horizontal line lies on the right side of this red line, hence it is positive, and this line segment 1, which is also on the right side of the red line, or this coefficient 2, hence this is also positive, so the solutions are 1 and 1.5. Now let's see another example where I change the sign of this constant term to be negative. We follow the same process. Draw a vertical line segment with length 2 units. As the sign of this coefficient is plus, so we'll go in anticlockwise direction or in this direction to a line segment of 5 units. Then we draw a line segment of 3 units in clockwise direction since there is a negative sign in it. So we go upwards. So this figure is quite different than the previous ones, so we extend the blue line like this. Then we keep the set square in such a way that the vertex touches the black line and the edge just touches the corners of this green line and the red line. Then we draw the lines like this. The same position can be obtained by putting the set square like this. So the two edges are touching the corners here and here, and the vertex is touching the black line. So we again join these two lines also. Then we mark a point at a distance of 1 unit from the end of this red line. Then we draw a horizontal straight line like this. Then let's measure the two distances. This distance is 0.5 and this distance is 3 units. Now as you can see, this length of 3 is on the left side of this red line, hence it is negative, and this 0.5 is on the right side of this red line, hence it is positive. So these are the two solutions. So I have again changed the sign of this coefficient. Draw a line segment of 2 units vertically, then draw a length of 5 units in clockwise direction as there is negative sign. So we go on continuing with this direction. So we draw a line segment of 3 units, but since there is again negative sign, so the direction again will be changed to anticlockwise direction. So we move 3 units upwards. We extend the blue line as we have done previously. Then we find the position for the set square in such a way that the two edges just meet the corners like this, and the vertex just touches the black line. Hence we draw the lines like this. the same condition can be made by taking a different position of z square, and this position is in this position. Hence we draw a line like this. Then at last we measure a point at a distance of 1 unit from the bottom part of the red line. So this will be the point. Then we draw a horizontal line in this. Then we measure the distance of these two lines, this and this, and found the length to be 0.5 and 3. Since 0.5 is on the left side of the red line, hence this will be negative, and 3 is on the right side of the red line, hence it will be positive, which will be the two solutions. So I have used the Lill's method, which provides an interesting way of solving quadratic equations. It is also explained in one of the videos of Matholo, so you can have a look at it. I have tried to modify it and make use of only the set square to solve the quadratic equation. So can you try it using origami or the paper folding? So some important links are provided in the description below if you want to have a further look on these methods of solving the quadratic equation. Till then, thanks for watching.